Hello Math 123 students. In this video, we're going to use Excel to explore some ideas related to loans and savings. Just a little bit of a warning up front. This is not entirely planned out, so it may not go 100% smoothly, but hopefully you'll learn some new things about loans and savings accounts, and you'll get to see all of the things that we've learned about Excel kind of used all at once in one kind of nice big fun assignment. Also, I might show you a few other things about Excel that you maybe haven't learned that are also, I think, kind of useful. All right, so we're going to start off by exploring a loan. Hopefully in a previous video, if you've been watching all of Becky's Excel videos, you learned about naming cells. We're going to be using a lot of formulas over here eventually, and we're going to want to drag and copy those formulas, and the cells that those formulas are going to reference, we want those to stay fixed. We don't want the cell references to move when we copy down. And so we're going to name all of these cells over here. We're going to put the price of the thing that we're going to buy. We're going to name it price. The down payment percent. We could say, let's see, DWN PMT percent. I'm going to call it that. Give it fun names. The down payment dollar amount. Give it a name. And all the rest of these cells we can also give some fairly obvious names. When computer programmers are giving their variables names, they don't necessarily always use the full name. They come up with fancy names for these things. And so that's why I'm coming up with fancy names for all of my variables. APR for the loan. And then finally, the payment for the loan. All right, so we got all these cells named. That way, if we ever need to use these cells in cell references, which we're going to use some of these in cell references, when we drag and copy the formulas, these cell references are fixed. All right, so let's suppose that we want to buy a house for $150,000. $150,000, not 15. Suppose we want to buy a house for $150,000. And I think in general, the banks want you to pay a 20% down payment, at least. Okay? So if we want to save up, you usually have to save up to make that down payment. If we want to save up 20% to buy this house, we're going to end up making a $30,000 down payment, which means that we'll need to take out, let's see, the price of the home minus our down payment. We'll need to take out a $120,000 loan. Okay? Now, I think a typical term for a home loan is about 30 years, so we'll go with 30 years here. That's the term for our loan. And I have no idea what kind of APRs are available for loans. Let's look it up. We got the internet. Let's look it up. Mortgage. Come on now. Mortgage APR. Okay. Mortgage interest rate and APR. Come on now. They're getting fancy here. What's a good mortgage APR? 30-year fixed rate mortgage with an interest rate of 4.25%. All right. So there we go. We'll use 4.25% as the APR for our mortgage. 4.25%. All right. So supposing we have all these parameters and we want to figure out what our loan payment is, we can use the PMT function in Excel to do that. Equal to PMT. We need the interest rate, the monthly interest rate. So we'll take our APR, divide by 12. We need the number of payments that we're going to make. We'll take 12 months per year times our loan term of 30 years. And then we need the amount of the loan as a negative number. So minus the loan. Okay, and it looks like we'll have to pay slightly less than $600 a month to be able to afford this house. That seems reasonable. But keep in mind, those of you who are paying rent, when you do buy your own home, in addition to making that payment, you also have to pay a lot of other things, like home insurance and tax and things like that are usually rolled up into your rent. So the fact that our house payment is smaller than a typical rent Don't let that confuse you into thinking, oh, it's much cheaper to have a house. It's usually not not as cheap. Also, you got to repair things and all that fun stuff. All right, so now one of the things I'm going to do, I'm going to round this. Now, I know it shows up as rounded. There's a difference in Excel between displaying a rounded value and actually having a rounded value. Right now, it's just displaying a rounded value. There's a function in Excel. It's the round function. Let's do that here. Okay, so there's a round function that takes a number. It needs a number and a number of digits that we're going to round it to. The number, when it asks for a number of digits, it wants the digits after the decimal. So when I tell it to round it to 2 digits, it's going to round it to 2 digits after the decimal. Now, I know it looks like the same number, but again, Excel was using the full value. It was storing the full value. We want to use the rounded value. We want it to have the rounded value there. Again, there's a slight distinction there. But anyways, now, if we wanted to know the total of all of our payments, come on now. I'm not going to name this cell because I'm not going to use it. We would just take our payment times 12 payments per year times the number of years, and we'd end up spending a total of $212,000 for this. The total interest that we paid would be the total of our payments minus the loan that we took out. So we end up paying $92,000 in interest. Interest as a percent of payments. If I take the total interest paid, this is a part the whole ratio. The total of our payments includes principal and interest. Right? The principal was $120, so the interest is a part of the total payments. So we got this part the whole ratio. We'll format it as a percent. So 44%. Give it a couple more decimals just to see what that looks like. All right. So the interest as a percent of our total payments when we buy this house ends up being quite a bit. Okay. If we want to do interest as a percent of the cost, the total cost, I guess if you look at the total cost of the house or the total price of the house, that has 3 components: the down payment, the loan amount, and the interest. Okay? So again, this is another part to sum ratio. We didn't really look at this one before, but as a percent of the price, 62, that's not right. That can't be right. It should be less. I must have typed in the wrong thing. Interest divided by the total price. 60, that can't be right. I guess it is. See, I told you this wasn't going to go smoothly. Oh. I see. Okay. Okay, so maybe this isn't a good ratio to look at. I wasn't thinking too hard about this one. But yeah, I was just dividing by the price of the house. So yeah, compared to the price of the house, the interest is a lot. This is actually not really a part to whole ratio. It's a different kind of ratio, but it's still an interesting ratio. Okay. All right. So these are some obviously computations that we can get done in Excel just using the Excel formulas and functions. What I will also want to look at is we can kind of treat this loan like a credit card thing. Okay, like we put $120,000 on the credit card and we're making payments each month. Instead of the minimum payment, we're just making the mortgage payment. Okay, and so it works a lot like the credit card problems from, section 10? So we start with a balance, that's the loan. Assuming we're making our payments at the end of the month, in that first month, it's going to earn a whole month's worth of interest. So I can take my monthly interest rate, take my APR divided by 12, and then multiply by the carryover balance, and that gives us the interest for that first month. And if I add that amount to the new balance, or sorry, to the carryover balance. That gives me a new balance. And then I make a payment. That's just going to be the loan payment that we decided to make. Notice that the interest here is slightly less than the payment. Okay? Let's get that formatted as a dollar amount. And then the carryover balance will be this new balance minus the payment that we just made. Again, just like we did with the credit cards. All these formulas are the same the second time around, since we're using named cells over here in our cell references. When I drag and copy, all of the cell references that need to be changed are changed, and all the ones that don't need to change are not changed. And then, let's see, I wanted to round these too, equal to round. I wanted to round these values too. So I'm going to round those to 2 decimal places, just like I did before. All right. Again, it doesn't look like anything's changing, but I promise you, Excel's treating those numbers as different numbers. All right, so I think everything's rounded to 2 decimal places, just like we do in class. And then notice I've got a whole buttload of months there already entered. If I highlight the cells I want to copy down and double click over here on the bottom right hand, on the button in the bottom right hand corner, it auto fills all the way down. And we can see the carryover balance getting smaller and smaller and smaller. Now again, this was a 30-year loan, so let's see, 360 months. The 360th month, that's about when we should go negative. And that's what happens here. All right, so we're not going to make any more payments after the 360th month. And actually, our very last payment is just slightly smaller than it needs to be. Again, that's due to the rounding. That's due to the rounding. So in this last month, we'll only pay the resulting balance, and we won't go $1.62 in the black. Okay, so now there's some fun things that you can do with Excel involving if statements. I'm not going to try to teach you guys if statements, but I could. There's some fun things that you could do with Excel to like automatically stop paying. Okay, so I won't do that here. All right, now what I want to look at here in this spreadsheet, now that we have this kind of amortization table, again, this is the kind of amortization table that we could have made with a credit card problem. We can look month to month. Okay, we have the percent of interest of our total payments. Like there's a total amount of interest that's paid, and there's a total amount that's paid, and we can figure out the total interest versus the total payments. But we can also investigate the monthly interest versus the monthly payments and see what portion of our monthly payments is going towards interest, percent of payment. Okay, so each on a month-to-month basis, not on a total basis, but on a month-to-month basis. And the computation is the same. Take the interest divided by the payment, and then format it as a percent. All right, so and again, this is the part I wanted to show you guys. Okay, overall, the interest 43% sounds like a lot, but in that first month, the portion of your payment that goes to paying off interest is almost 72%. Okay, and if I go ahead and copy this down, it's a reasonably high percent for a long time. It doesn't dip below the halfway mark until month 165. All right, that is how many months? That's like 13 or 14 years. 13 or 14 years into this mortgage. Almost halfway through this mortgage, all our payment is more than half. Interest is more than half of the payment. Okay? Now, as we go further along, the percent of our payments continues to drop. We're at the end of this right here, the very last payment that we make, where the portion the portion of our payment that's paying interest. These interest amounts are very small relative to the beginning, okay? So the reason I wanted to show you this is when you take out a loan like this, at the beginning of the loan, whether it's a 30-year loan or a 6-year loan for a car, at the beginning of the loan, a large percentage of your payment is going towards just interest, okay? And so if you're looking at, let's say you got a 30-year loan and you're able to make payments for 5 years, that gets us to month 60. 5 years gets us to month 60. On this $120,000 loan, after paying for 5 years, making 60 payments, we've only paid off $11,000 of that loan. Okay, if we look at the total of the payments up to that point, we've paid $35,000 in payments. You can see down here at the bottom, there's the sum. Made $35,000 in payments, but only $11,000 of those dollars went to actually paying down the principal. Okay, almost two-thirds of those payments is just interest. Okay, and so they call it equity. You don't have that much equity in your home if you've only been paying for 5 years. And the banks know this. All right, we talked about, the banks are in this to make money. Banks don't necessarily want you to default on your loan. But they know if you're only able to make payments for 5 years that they've made a lot of money off of you in those 5 years. Okay? And that's why they're able to take your house away from you and sell it for much less than what it's worth to get their money back. All right, they've already gotten $35,000 from you on $120,000. They only need to get $85,000 back. So they only need to find someone to spend $85,000 or $90,000 on your home. That's worth probably more than $150,000. All right. Keep in mind you already gave them $30,000. So, that's one thing that you'll want to keep in mind when you're taking out these loans. You really are, for these long-term loans, especially mortgages, you really are in it for the long term. Okay. And at the beginning of those loans, you're not really building any equity or not very much equity in your home. Okay. You really do need to take that into consideration. Now, if we shorten the loan term here to 15 years instead, all right, notice right off the bat, the percent of your payment that's going towards interest is much, much smaller right off the bat. Okay, so that's why the shorter term loans, if you can manage it, that's the way to go. Obviously, your monthly payment goes up significantly from about $600 to about $900. So your payment increased by 50%. You should be checking these numbers at home, by the way. Payment increased by 50%. But the interest goes way down. So the shorter, the bigger payment that you can make over and the shorter term loan that you can get, the better off you are in the long term. Again, even going 20 years as opposed to 30 years makes a big difference. And so looking at this 20-year loan, if we look and see how much of our principal gets paid off in the first 5 years of that, again going to 60 months, we got a little bit more than $20,000 that we've paid off. How much money have we paid in total? That's $40,000. So still, I guess still, again, that first 5 years is still pretty beefy. Still pretty beefy in terms of the payment to equity ratio. But all right. So that's some interesting things about loans. By the way, this spreadsheet should be made available to you. I should have said at the beginning of the video. This spreadsheet's available if you want to go back and download it and play along. You can do that, and you can also fiddle with some of these numbers and see what happens when the interest rate goes up and the term goes up. You can play around with it a little bit. All right, so looking at savings now. Let's pretend that we're making $40,000 a year. And again, this one of the things about savings, the savings problems in this class is they kind of assume They kind of assume a fixed yearly income over a long term, which is not necessarily true. But again, for the purposes of keeping the computation simple, we can go with this. All right. So if we want to figure out how much to put into our savings account, okay, we need to first figure out a monthly income. So if we're earning $40,000 a year, our monthly income, just take that divided by 12. Format that as $1. And then when I was growing up, my dad told me that I should be saving 10%. 10%. Now, not all of that's going to retirement. So let's say maybe 5%. I want to do 5%. Some of that savings is, rainy day stuff and fixing houses and things like that. Some of that savings is retirement. So let's say we're saving 5% a month towards retirement. We're talking about a retirement savings account here. All right. And so if we want to figure out what our monthly contribution to our savings account, our retirement savings, we can take 5% of this $3,333, and we'll go ahead again and round. I want to round this number, or have Excel stored it as a rounded number. And so we're going to be putting a little bit more than $166, or just shy of $167 into our savings account. All right, so supposing that this person is going to be saving for, let's say, 40 years. Let's suppose that this person's young and they're going to save for 40 years, and they're going to earn a meager, let's just say they're able to invest and earn like 5%. Okay? We'll just make up a number. Why did I say 2.6? Let's do 5.25%. All right. So each month, they're going to be making this monthly contribution. By the way, I've already named all these cells. They're going to make this monthly contribution, the same monthly contribution every month. But like we talked about in the example in class the other day with the student loans, each contribution is going to earn interest for a different amount of time. Okay? So this first contribution, let's say we make it at the end of that first month. Okay? If I want to know how many months it's going to accrue interest. It's going to accrue interest for almost the entire savings term. So 40 years times 12 months a year, but not that first month. Okay, again, we're pretending that we're going to put that money in the bank at the end of that first month. So it's not going to earn interest for that first month. Okay? So it's going to earn interest for 479 months out of the 480 months that we're going to be saving. And then the end balance, this is where we use our compound interest formula. Take our principal times 1 plus our interest rate divided by the number of times we're compounding a year. This is a monthly account. And then, like we talked about in class, rather than doing 12 times the number of years, we're just going to do the number of months. That's why I computed this value here. Okay, so let's go ahead and format some things as dollars. And I should probably round these numbers to, well, no, I'll go ahead and leave these numbers unrounded. Okay, so here we can do interest earned. Interest earned. Everything of this imbalance that's not what we put in is interest. So that first month's worth of contribution earned a lot of interest. Okay? So, let's go ahead and copy all these down. Now notice that the interest that we're earning goes down the further we go here. Let's see, 40 years is 480 months, so I guess I want to delete everything after 480. I think I went out 50 years instead for some reason. All right, $480. All right. So notice that last deposit there doesn't earn any interest because we just put it in right at the very end of our savings, and so it's in the bank for like a day, and then that's our savings. Okay. All right. Now, if we look at the sum of all those, it tells us that our savings account is worth $191,579.11. That should be the value that Excel spits out when you use balance for 40 years. If we use the FV function, that's the function in Excel that we use to find the future value of all of our deposits. We take our interest rate divided by 12. The number of payments is 12 times our savings term here. And the amount of our payments as a negative is that amount there. All right. So that says did I do 40 years worth of stuff here? Uh-oh. Like I said, this wasn't going to go smoothly. What happened here? Oh, I'm just looking at interest earned. There's our end balance there. Sorry. I was looking at the wrong column. There it is. The end balance. We're looking at the end balance of all of our deposits, not the interest earned, but the end balance. There it is right there, $271,580.71. So again, the default computation that Excel does for this FV function is assuming that we're making these contributions at the end of the month. Now, one of the things notice that there are a couple of optional arguments for Excel. This type is the one that kind of, if I wanted to make my deposits at the beginning of the month, zero present value. This, by the way, this PV, if you were starting with money in the account, like if we were starting with, if Grandpa gave us $10,000 to get us started off on our lifetime of savings, that's what you would put in for the present value of your savings. Then the type, notice here, 0 is the default one at the end of the period. If we wanted to make our payments at the beginning of the period, that means that we'd be earning a little bit more interest. The value doesn't change too much. All right, so there's a new thing about this PV function that you maybe didn't learn from Becky's videos. But we'll go ahead and go back to the account balance at the end of 40 years. Okay, so notice again that the amounts that are in the account for longer, or the amounts that you put in earlier, are worth a lot more at the end of 40 years than the amounts at the end. Okay, even going halfway. The halfway mark would have been the 240th month. Like, notice this amount that you put in at the halfway mark, it's only worth $300 at the end of the 40 years. Okay, and so that's why the earlier that you can get going saving, the better. Now, one of the things I want to investigate here is we've had some. I'm going to go ahead and take this amount, and I don't want it to be a function anymore. I just want to save it as value. So one way that you can do that, I just did a right click. If I do copy, and then if I go to paste, there's a couple of ways to get this done. It used to be that you had to click this paste special, but they already had these things up here. If I just wanted to paste that value, now it has that just stored as the number. Okay, so that's not going to change now. This number's not going to change now if I change these numbers up here. What I want to look at, we've had some examples. There was an example I think that Becky did in the videos, as well as one on your homework, that are talking about, so-and-so saves this amount of money for 40 years, and their friend or their sister or their brother says that they're going to put double the amount for half the time. Okay? And the half the time is focused on the last half. Okay? So that's what we're going to do here. We're going to look at, but we're also going to look at the first half. Okay, so we're going to look at a couple of account balances. And again, our total contribution is going to end up being the same here. But instead of one person, we got the first person does it evenly over 40 years. A second person is going to do a second. It's going to do second 20. That's a D. Second 20. But we're also going to look at a person who does it for the first 20. Account balance. So they're going to take this entire contribution, and instead of spreading it out evenly over 40 years, they're going to double their monthly. They're going to double their monthly payment, but do it all in the first 20. Okay, so we're going to take this monthly contribution and double it. So just two times that value. So there's our double amount. Now, I still have the savings term for 40 years here. We're just going to, for the first person, we're going to look at the first 20 years worth of end balance. Okay, so the person who saves double the amount for the first 20 years, you can use the sum function here. Just add up these end balances for those first 240 months. So we can quantify the difference here. Okay? And the person who saves for the second 20. All right, so think of these first 240 contributions are this person right here, and the second 240 contributions are the other person. So contributions 241 through 480 are going to be the lazy saver, the person that doesn't get on the ball. Okay, so again, the things that we are exploring so far in class are these two people: the person who saves evenly for 40 years and the person who saves double the monthly payment for the second 20 years. Notice how much smaller the balance is for the second person. Okay, but the new thing that we're looking at is that first person. Holy cow! Look at how much more money they have. Look at how much more money they have than the person who saved evenly for 40 years, or they got almost three times as much as the person who saves for the second 20. So as good as saving over 40 years is, if you can get that money in early and then just let it sit there. Again, this person here invested really, really hard for the first 20 years, and they didn't save anything after that. They just let their money sit there for the next 20 years. Okay, this is really the way to go. All right, so if you're able to do it, again, not everybody can. Everybody's circumstances are different, so don't feel bad if you're not able to do this. But the best advice that you can be given for people who are still young is to save as much as you possibly can in your 20s and 30s. And then you're going to be able to go hog wild after that. I promise you. Okay. Now, I mean, again, if you make a decent wage and live modestly, you can live high on the hog in your later years. Okay. All right. So those are the examples that I wanted to look at here in this video. I hope that you learned a little bit of something about the finances involved here and got to see all of the fun things that we learned about Excel in use in this example. Thanks for watching.